create the opportunity for the students to design their own research question and have the experience of figuring out what kind of evidence they need and what kind of apparatus they need to build in order to answer the research question that they've posed. I think it's much more fun to explore things and to create things. And also the idea of exploring and creating is much more like what real scientists actually do. So I wanted to give the students that experience at as early an age as possible. So there's an iterative process of thinking about what kind of apparatus you're going to build, taking preliminary data, analyzing the data, seeing if it makes sense, going back to check if you've answered your research question or not. Did you really gather suitable evidence? And it's best for the assignments to be very open-ended and also for the assignments to capture the imagination. And so if they feel like they don't know what to do, that's really excellent. They should just try to understand what they do and don't know and figure out what to do from there. So at this point in the quarter, we tell them to identify some project that is related to rocket-based or ballistic transport. And so a lot of students do things that are related to catapults or trebuchets or rockets, but it's very open-ended. And the students should own the process. So it's definitely the hardest part of teaching this class, both for me and I think for the teaching assistants, not to tell the students, just take this data set and you'll get a really pretty answer. And also the students constantly have questions like, can I use this? Can I assume this? Is it true that this? And I try to answer those questions in very open-ended ways. Like, I don't know, what would happen if you use that? Or, I don't know if you can assume that. Does it matter if you assume that? And sometimes when I do hold back from telling them exactly what I know, I find out that they surprise me and they do something that's much better than what they would have done if I had told them what to do. So a lot of these questions are questions that you could imagine asking in any high school science fair in the country. What makes it different here is the quality of the peer feedback.
There's no way to fix that.
So we have slightly structured exercises
You only need a 1 centimeter.
where we ask the students particular questions and have them work together in small groups
And then we also have a launch angle from your
to share their research process with each other and get peer feedback. If you watch the students talking to each other, you can see how much they learn from explaining what they're doing to somebody else, and you can also see how much they're learning from trying to criticize somebody else's work. Because we do this very student-driven, time-consuming research process, the students only have time to do 2 or 3 experiments in a term, instead of doing 1 experiment every week and doing 10 experiments in the term. But I really do think they learn a lot more from each one, and more important things too. How do we decide what teaching has value? How do we decide what is it that we want to teach the students, and what's the best way to help them get what it is that we want them to get out of the class? That would be my general message. I hope they'll take away some understanding of how messy and imperfect research really is, and also how difficult the early stages are. The stages where you conceptualize things are, in some ways, the most important stages, and they're stages that you need to go back to again and again. Scientific research has a lot of loops in it where you do something and then you do the next step and then you realize you have to go back and do the first step again, and then you get to the 7th step and you have to go back and tweak the 4th step. And that way, when they start to actually do research themselves and they start to create an original knowledge themselves, they'll take those bumps in the road in stride because they will have already experienced that in the slightly more controlled, well-mentored environment of a lab class. And then for my fellow instructors, I guess I would say that I just think it's so much more gratifying to see the students being inspired by something that they thought of and something that they made work than it is to see them getting exactly the answer that you told them that they would get and that you knew that they would get before they started the process.